All right, 0.825. You still have one from yesterday. 0.825 in your calculator. I'd like you to change that to a fraction. It's under math. This whole day is just about how to use your calculator better. And there are some really cool tips in here. So under math, and then you hit enter, enter, and you get, it turns into a fraction. Easy as pie.
Ours looks different.
Oh, some people's looks different. Yours has the new operating system. So yours has it as like this, 33 over 40. They figured out a way to make it actually like a normal fraction like this. But on a lot of your calculators, you don't have that. In fact, how many of you, I'm curious, how many of you have it like this, over the top of each other? Then you have the new operating system. How many people don't have that operating system? All right. Now look at your calculator quick. See if yours says 83 or 84 on it. If yours says 84, then you can have the new operating system. If yours says 83, sorry. Now, how many of you have it 84? Yours is got a big enough brain to handle this new operating system. All right, then if yours does not have the pretty print, we call it, basically it doesn't change too much, but if you want the new operating system, see me after class, and I can take one of my calculators that does have the new operating system on it. I hook it up with a little link cord, which I have in my desk here, and then I can give you that new operating system. All right. Let's go on to the next thing. I want you to see how your calculator can round for you. Your calculator can do the rounding. You know how if you're asked to round to 3 decimal places, it's not that hard to do, but I'm telling you, in a group this size, oftentimes I'll have 1/4 of the kids will make a rounding mistake. And so you can prevent that, guaranteed, by having the calculator do the rounding. Go to math, and then arrow over to number. And then go down to number 2, it says round, and hit enter. And it doesn't automatically round because it doesn't know what you want to round. You have to put in a number, so let's type in this one. After you say round, say 2.598632. Then you have to tell it where to round to. So you say comma, and by the way, the comma is the button that is, where is that thing? It's right above the 7 button. Right above the 7 key on the calculator. There's a comma there. Say comma 3, and it'll round it to 3 decimal places for you. The same thing, of course, if you wanted it to only round to 2 decimal places or 1 decimal place. I'd like you to try to have it round to -1 decimal places and see what happens. 2.7, that doesn't make any sense. 2.598632, and then what would rounding it to the -1 decimal places do? Can it handle it? It says error. And then, no, wait. At the error screen, do you see what it says? Go to or quit. If you do go to, do you know what that does? It goes to the error. And if it goes to the error, it should show you that the error is right at the end there. See what I'm saying? So you can tell that, oh, it can't handle a negative in there. So I guess, how about if we round it to 0 decimal places? Can it do that? Try to do a quick round to 0 decimal places. And then it'll just round it to the whole number, I assume? Okay. All right. Do you know what? You know what? Let's not. These are all fairly ones that you could play around with if you wanted to know, but we're not going to use them very much. If we tried to teach you every single thing your calculator can do, seriously, you'd take a week doing it, and like 90% of it you would never use. We've culled it down to you are actually going to be able to use all the things we show you today. All right. Next thing, this is not under basics, it's under math again. Go to LCM and put in 15, 14, and LCM stands for least what? Common multiple. All right, snap out of it. LCM, 15, 14. Otherwise you'll be moving soon. It's under math, LCM, it's the 8th thing down. You have to arrow down until you find the 8th thing. All right. Now, what is LCM good for? It's also known as the least common denominator. So if you've ever needed to find the least common denominator for a couple fractions,
Oh my god.
That'd be really handy. All right. I wasn't there 2 years ago. And GCD. All right. GCD does not mean greatest common denominator. That doesn't make any sense, actually. If you have a GCD of these two numbers, let's try to figure out, if you just look at them for a second, if the answer is 2, what the heck do you think GCD is? Come on, somebody can do it. Greatest common is correct. Not decimal. Divider is really, really close. Divisor. Divisor means what is the number that will go into both of these. Okay, and the only number that goes into both of them, I shouldn't say the only, the biggest number that goes into both of them is 2. Let's do another example. Let's say we had 21 and 14. Do you agree? Oh wait, let's go with something else. Something is okay, 42. And something else that has something that'll go into it besides 2. How about 24? Now, do you agree that 6 goes into both of those? All right. I want you to find the GCD of 42 and 24. 2 goes into both of them, but 6 is the what? The greatest of the divisors. Yes, that would really help for factoring, wouldn't it? Okay. Now, you know, I guess you can think of it this way. You guys are saying, why didn't you tell me this when I was in 6th grade? Well, at least I'm telling you when you're in 9th grade, and you'll be able to use it 10th, 11th, and 12th, right? At least you know these kind of things are in here. If you just have to know that they're there and you can look for them. What if you wanted a giant list of every single thing the calculator can do? Do you know where it is?
Online.
It's on your calculator. It's one of these buttons. Not list. Nope. Stop reading every button.
Math.
Catalog. There we go. Somebody actually found it. Way down bottom above the 0 key, you see the word catalog? If you arrow down and just hold the down arrow, that's every single thing the calculator can do.
Press one of them, like something popped up.
If you ever want a list of all the things that are on there, catalog is awesome. Because if you know that's there, but you can't find it, are you also noticing that this thing is alphabetical?
Yeah, and you can type in a letter and it'll find it.
Ooh, I didn't even know that.
Look at it.
So like if you're looking for binomial, you type a B,
Yep.
and it like pops up.
Oh shoot. B?
Ooh, sweet.
So when you like press it, like.
So catalog button is awesome. That gives you a list of everything that's on the calculator. All right, next thing. I'd like you to go to your y equals screen and graph these two things, y equals x and y equals x squared. And then when you are done in a minute, I'm going to ask you to hold your calculator up and show me that you got the graph correct. So everybody get this done rapidly, please. Y equals x squared. Make sure it says you hit graph and make sure you look at your neighbors and make sure yours looks about the same as theirs so that you're not doing it wrong. In a second, I'm going to ask you to hold it up so I can see it, so I can make sure that I got almost everybody in the same spot, because this next thing is important. Okay, hold it up so I can see it. Hard to see some of those. Somebody's not done. Hurry up. And I got, okay, there you go. And yes, good. Thank you. Everybody's on the right page now. Okay, I want you to zoom in on the spot where they cross. Now, there's two ways to do that. A lot of people don't understand when they hit zoom. Everybody go to zoom. Just plain old zoom. Zoom, and then on the choices of zoom, do you get zoom in as one of the options? Hit zoom in and hit enter on zoom in. And do you get that it has not zoomed yet? What is it waiting for? Why doesn't it just zoom? It wants to know where you want to zoom in, and it has put a little plus sign on your screen. That's what it's waiting for, is you move the plus sign to where you want it to zoom in. So for people following along at home, so if I have y equals, and I say x, and then I go down to this one and say x squared, I can zoom in on any part of this that I want to by doing zoom in, but as soon as I hit enter, it doesn't actually zoom. You see the blinking thing though? I move the little blinky thing and say, you know, I'd really like to zoom in kind of over here or wherever you want to zoom. And then you hit enter. And it'll focus the zoom on wherever you put the plus sign. How many of you didn't know that? Thank you for being honest. Okay, good. Now there's another kind of zoom. Let's say I know the area I want to zoom in on is like in this little area like right here. Well, how can I zoom in on a little box like that? You use zoom box. Z-box. So if you want to see Z-graph, you use Z-box. Pretty bad, I know. All right. So now to draw my box, I start in the upper left-hand corner. You can actually do the box any way you want to, but I personally start with the dot there in the upper left, and then I hit enter, and then I move over, and it starts dragging my box. And you're doing it wrong. And I'm sure that's very helpful. Some interference here. And then I hit enter. My All right, so there's zoom box. You can zoom in on any area you want to. There's another zoom that's kind of cool. And let's do it right now. Do Z square. So I have the same graph up and do zoom square. Can you tell the difference between that and the normal zoom, which is zoom 6, standard zoom? All right. I'm zoomed in too far. I'm going to do a zoom 6 first. Zoom 6 to get, this is like normal. Everybody, please do this difference. Sorry, where you were, if you hit Z square from there, it probably looks confusing. Go zoom 6 first. Do a zoom 6, and then do a zoom 5. Do you see a slight difference in the graph? Do you know what the difference is? Did you know that the standard zoom, the zoom 6, the zoom you've been looking at for your entire life on this calculator, however long you've owned it, is actually off? It's actually stretched a little bit. It isn't right. It isn't like exactly straight unless you use zoom square. Zoom square means that the x little, what they count by on the x's and what they count by on the y's is exactly the same as each other. Why do they do that? I don't know. I wish they just had zoom square in the first place. So all your graphs were like, their x intervals and the y intervals would be the exact same thing. The tick marks are always the exact same distance apart. Anyway, but if you want your circles to look like circles, see the difference? This is your standard window. It looks kind of like an oval, doesn't it? And if you do it in zoom square, then it'll actually look like a circle. Okay, so next, shrink that. There's a trig zoom too. Everybody graph the sine of x on your y equals line. And then do zoom trig. Well, we've done some trig lately. We haven't graphed much trig, but you do a lot of that next year. So if I go to y equals sine of x, and then I go down and clear that one out, and then I go graph. Normal graph. You see how the normal graph is not looking very pretty on that zoom? Now if I do zoom trig, number 7, it's a very nice sine curve. Okay? So it's all about what you're zooming into. All right. By the way, in case you don't know this, from the start to the end on one of these things is one full cycle, and those are really important. And so that's why this is particularly nice, because it's got exactly 2 full cycles of the graph there. They're called periods of the graph. All right. Moving on. Did you know that your calculator has degrees or radians? All right. Did it ever bother you? Hit the mode button. Hit the mode button, everybody. Did it ever bother you that we always choose degrees and that's not the default? Like, I mean, if you look at it, look at our list. Don't we have everything defaulted to the left except that one thing? That one thing is to the right. Why? Well, actually, I found out from the calc teachers that they actually defaulted to radians. They use radians the entire time in calc because radians become way, way easier when it comes to trig. And so they use radians all the time. So then how the heck do they enter stuff in degrees? Well, let me show you. Everybody get yours to radian mode, and I'll show you how you can still do degrees even if you're in radian mode. Okay, go back out, quit out of this to the main screen, and let's do sine of 30 degrees, sine of, if I'm going to, or 45 I guess is what's on the screen. It doesn't really matter which you pick, but I'm putting in 45. Do you know how to make it be degrees even though we're in radian mode? That's a good guess, but no.
What about 180?
Nope, it's not a divided by thing. Put the degree sign. Where is the degree sign? It's under angle, which is right above apps. So it's right here. The little button's red now. And see the top one? That's a degree sign. And if you hit enter, you'll have said sine of 45 degrees, and you made it very clear to your calculator that you don't want radians, you want degrees. You're forcing it to use degrees even though it's in radian mode. All right, now that's extra work, but it will guarantee that you won't by accident have an answer in radians. All right, and when you're in calc a couple years from now, they'll be telling you to do it this way. So I'm just showing you now. Yes, sir?
What's the difference between radians and degrees?
Radians are really big things to measure with. It's a lot like this. Do you get how in our system of measurement we can measure things in inches or we can measure things in feet?
Yeah.
And inches are really small, right? Well, we can measure things in degrees or we can measure things in radians. Degrees are really small. Radians are much bigger.
Okay.
Radians are about 60 degrees.
Do we ever need radians or degrees?
You won't need them this year. You will start using them next year, and I'll explain all about them next year. Okay?
So if we change it-
Radians are just like a different thing to measure with, just like you can measure in feet or yards. I mean, couldn't you just measure everything in inches? Yes, you could. But it would get a little clumsy once you're starting to measure things that are really big, right? So we start measuring in miles. Same idea with radians and degrees. Radians are just like big things to measure with. And they actually have a lot of advantages in trig, which we'll show you next year. All right, moving on. The store button. If you have a number that's really important to you and you want to save it, you can store it. You can store it under a letter. Never store it under X because I'll show you why later, but right now we're going to store something under A. I want you to pick your favorite number, don't care what it is. Put any number you want in there. Maybe it's 3.141592653588737. No, dang it, I screwed up pi. Anyway, figure out a number, any number, type it in. And then we're going to store it somewhere. We're going to store it under A. Do you see the stow button? The stow button is right above the on key, like where you go to turn on your calculator every day. Right above that, the one right next to it there says stow. You're going to store your magic number, whatever it is, under A and find the alpha button to type the A. Just the green button on your calculator. All right, so for me, let's say I'm going to do 3.14 as my magic number I want to store. And I'm going to go to stow, store it under A, and I go to alpha A, and I hit enter. Now why is that cool? Because now, guess what? Every time I type in an A, guess what's going to come up? 3.14. So if I wanted to do 2A squared, where A is 3.14, I go 2A squared, and it will take A squared. 3 squared is 9, and 9 times 2 is about 18, so it should be about 18 or 19. There it is. You get what I'm saying? It took A as 3.14, whatever I said it was. Yes?
How do you, like, unstore it?
How do you unstore it? Well, your calculator has stored something under every single letter. It's stored a 0. So if you want to get it back to the way it was, store 0 under A. So like if that bothers you that we got this weird number stored there, it goes 0, store it under A, And now it'll be back to the way your calculator started. Okay? So now, can you see how that could be handy? Could you actually use this to store your lists of your phone numbers for your friends if you wanted to?
Yeah.
Sure, good. Now, I don't know why you'd want to multiply your friend's phone number by 7 or whatever, but you could store anything you want in there. Now, how about a math problem where you're going to use the same ratio, 1.618, over and over and over again? You're going to like times it by that, you're going to divide it by that. You see how that'd be handy to store it under A? All right. Okay, now you know you can store stuff. Moving on. I'd like you to type in these two equations, please. 2x plus 5.4 and negative x minus 2.78. Notice one of those is a negative and one is a minus. One kid last hour had those messed up and it wouldn't graph for her. So get those two in there, hit graph. Now what I want you to do is calculate the intersect, and I know you've done this before. It's basically where are those two lines intersecting. You go second calculate, it's right above the trace button, and you're calculating the intersection point of those two lines. If you've never done that before, I will show you quick. 2x plus 5.4, 2x plus 5.4, and then negative x minus 2.78, and I hit enter, and then I hit graph, and then if I, oh wait, mine's not showing up real nice, I'm going to use zoom 6 to get a nice standard zoom for it. Zoom box I could do if I knew where I wanted to zoom in, wherever. Now if I want intersect, I go second, calculate the intersect. I don't know, have you not done this? Maybe you never have. Okay, go down to number 5, the intersect, calculating the intersect, and it says first curve. That means what's the first line you want me to check the intersection point for? In other words, what if you had 10 lines on your screen right now? It wants to know which of the lines you want to find the intersecting spot. So if you're only ever did this when there was 2 lines on the screen, it wouldn't have to ask you this. But if there's multiple lines, it would have to ask you which one. It says curve, I wish it just said line. First line, there. And then it jumps over to the other line. Second line, there. And then it says guess. That means it might intersect in more than one spot, and you want to, it's asking you which spot kind of does it, basically it's about there that I want. So I get close, and then I hit enter. Now do you see it has an intersection point there? If you were a really smart computer and you wanted to save your user some time, where would you store those two numbers for you? Under a letter. What letter would you store X under, maybe? X. My point is, did you know that the calculator automatically then stores these in X and Y? So like now we know X is about negative 2.7, right? Let's say we go off this screen and we go to our other screen, so second quit, and you just hit X. Just hit X, and I hit enter. See it? It's right there. It's stored it under X. Do you get that? Yes. It'll stay there until you do the next intersection point, or the next, you can always change it if you want. You can store something else under X. But that's why we don't recommend you store anything under X or Y, because that's what your graphs will do. Whenever you make graphs like this, it'll store stuff under X and Y for you. All right, so if I wanted to know what Y was, do you guys know where Y is? Right above the 6. Oh, it's a V. Dang it. Above the 1, thank you. Let's see what it says for V. Now it says 0. See, it stores 0 under things unless you've used them. And it's above the 1, so I go Y, enter, and it says there's my other part. That's where the Y was of where they crossed. Okay, so it stores those things automatically for you. I bet you didn't know that. I didn't know that before. All right, did you know that your calculator can graph these kind too? It can shade above or below a line. Did you know that? Yeah, I know. We didn't want to tell you because it would be too easy. All right, so I want you to type in these two equations into your y equals. this little thingy right here is how you shade above. This little thingy is how you shade below. If you arrow over to them and hit enter until it's the way you want it. Okay, so type in the equation first. You know how to do that. And then just go over here, you arrow over, doot, 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 until you get to this little area. And then you hit shade above or shade below. And I'm going to walk around and see if you get your shading in the right direction. If you have trouble with that, at least have your two equations entered.
Is that one in Z-squared?
My graph is on a z-square, yes. But if yours is on normal zoom, that's fine. All right, I did a quick check. It looked like everybody figured this out. So, yeah, how you get it back? How do you get them cleared off so that they're more normal again? Otherwise, from now on, whatever you graph in Y1 is going to be shaded. It's going to annoy you. So go back, change it back to just a slash. Make it look like this. Yeah. Okay. 4 times apparently. We'll get you back to that mode. All right, a couple more things. Data, putting data into lists.
This is a lot of stuff for me.
Yeah, I know there's a lot to learn, but here's the good news. No homework tonight. This is all we're doing. Just doing this in class today, and then you got nothing else tonight. I know, you've had a lot of homework in a row, but tonight's a night off. All right. I want you to put these 7 numbers into list 1. This is under stat. Stay with me. Hit stat. Once you're in stat, hit edit. Then in your list 1, L1, I want you to type in those 7 numbers. It's 158, 348, 6. 158, 348, and a 6. Okay. So your top number here. If you do calculate now, it's also under stat. Calculate the one variable stats. You'll get this big list. Get that up on your screen. Compare it to your neighbor. Make sure your numbers are the same as theirs. Make sure that you're doing it right. If you're lost, get help from them on how to get it in there. Because we got to talk about those in a second. Any questions about this? Let's see. Okay, your numbers are off. That means one of your numbers is wrong in your list. Look at your list again and try again.
Did you see that one restaurant that was like, yeah, with all the I just did this.
And hit enter.
Oh.
There you go. Good. All right.
I'm getting this.
Okay, so I go stat. Let's do go to and see why I won't do that. All right, so let's go to stat. Edit. Oh, this is on L6.
What's that?
That's list 6. So you didn't put them in on list 1, you put them in on list 6.
Oh.
Do you have any programs saved or anything? Can I just wipe this?
You can wipe it.
All right, so I'm going to get back to factory settings. There, now it's back to perfectly clean, and now you'll have list 1 in there again.
Okay.
And I'll go to edit, and there's what? Okay, set memory. I must not have reset everything. When it's done, it'll be fixed.
Party in here. Should be the best.
Got what? What? Good, good. Talk to me later about that. Okay. That top bar there, X bar. Turn around, please. Thank you. That means average. So all it's saying is the average of the numbers is 5. It found the average for you. This one, what do you think the little squiggly thing means there in front? That means sum. That means add them all up, and what do you get? So it took all the numbers and added them for you. This one you would probably never do on your own, but it's something you use in stats a lot. It's called the sum of the squares. That means it squared all the numbers and then added them. Next thing is SX. That means standard deviation of a sample. That means it took a sample of the data, like when you poll to see who's voting for Obama and who's voting for Romney, do you actually ask every single person? No. Even when we vote, we don't ask every single person. It's whoever comes and votes, right? So if you're doing a poll, like you want to find out, you don't ask everybody, you ask a sample of people. And then you say how many of you are voting for Romney, how many of you are voting for Obama. And this would be a standard deviation of a sample. What it means is if you take this number, this set of numbers here, as a sample out of the whole real world, that the standard deviation was 2.58. What does that mean? What that means is how far was the normal number away from the average? Do you get that 1 was very far away from the average in the group? How far away was it? 4. What it's saying is, how far is the average number away from the average? So like, we'll try this one. How far away is 5 from 5? It's not far away at all. How far away is 8 from 5? 3. And what it does is figures out the average of all of those. How far away is it from the average, and finds the average of that. Now, why would that ever be handy? Standard deviation would be, for example, when I went to Japan, I lived there for like a month during college. I highly recommend if you can get a chance to travel during college. It's awesome, give you a perspective on living someplace completely different. So I lived in Japan, and in Tokyo, when you got onto these buses, it was amazing. Like everybody was about the same height. Seriously. Like it was just amazing. Everybody was like the same. In the United States, is it that way? No, we got huge differences. We got short people, we got tall people. Okay, Africa, I can also give it as an example, has a tremendous difference in heights of their people that live in on the continent of Africa. Because you got anything from pygmies to, what's that tribe that has the 7-foot tall people? There's, in Africa, there's a tribe. No, it's not because of the stretching themselves. This is like, I think it's the Maasai. Have you heard of Maasai warriors? Yeah. Anyway, there's a tribe of Africans that is like averages about 7 feet tall. And there's another tribe that averages about 4 feet tall. And then there's all in betweens. Okay, so there's a big standard deviation in Africa. There's a very small standard deviation on the island of Japan. Like everybody's almost the same height. So if you take a set of data and I say there's a high standard deviation, I want you to think, oh, that means that there's a lot of differences. Like in the United States, there's a high standard deviation on wealth. In other words, there's a lot of people that are, you know, like poor, a lot of people that are wealthy, a lot of people in between. Okay, so you grab an average guy off the street, he might be a multimillionaire, might be a billionaire, and he might have like $0 in the bank. Big difference, okay? And in some socialist countries, you're going to have people have more of the same. Like you grab the average person, they all have about the same. Not very much usually, but they're all about the same. Yes? The Watusi? Okay, what was their average height? Does it say? The average height of that African tribe? 7 or 8 feet tall people. All right. Doesn't say an average, but it says that there's a lot of really tall people. Okay. Let's move on. This little thing is kind of handy on your list. And it is n equals 7. What do you think that stands for? From our data, what do you think that is?
The number is less than 7.
Nope. Thanks for guessing. Nope. That's somebody else guessed that. It was the one thing that wasn't listed. You're right, but it's not that's not what they're saying. There's 7 numbers in the list. Yes, that's all it is. There's 7 numbers in your list. Now, why is that handy? Because what if you're supposed to put in, for some science project, you're supposed to put in 100 pieces of data, and you're all done, and do you really want to count all of them? It'd be nice to be able to do this quick thing and say, is there really 100 numbers on my list? Yes. You know what I mean? You can check that really quick, how many numbers there are in your list. All right. Now, what do you think sort does to your list?
To make it lowest to highest.
It sorts it from lowest to highest. You're right. Since they're only numbers, there's no letters. You won't do alphabetical, of course. It will just take your numbers and order them from smallest to biggest. Why would that be handy? Well, sometimes you want to know the middle one to find the what? The median. To find the median, you might want to make them a list of them and from the smallest to the biggest one. All right, so that's sorting your list. All right, almost done. The last thing we need to talk about is box plots. We need to learn how to make one. You guys have heard of box and whisker plot? You can make one like this on your calculator. And what we're going to do is take the same data we had on our list. Okay, and it doesn't matter if you arranged it from smallest to biggest or not. If you didn't sort it, that's okay. It should still work. Now we're going to do a plot, a stat plot of our data that's on list 1. Anybody want to look on here and see if you can find stat plot first? It's above the Y. Very good. It's the very top left thing. So it's right above it's the very top button on the left. All right. Now, a stat plot, if I go second, the Y equals button, I have stat plot. There's plot 1, plot 2, and plot 3. Basically, you can have 3 different plots going at the same time if you want to. Okay, we're just going to go into plot 1, and we're going to turn it on. So once you go into plot 1, hit enter, and when you get in there, it's defaulted to off. You're going to turn it on. Okay? And next thing it asks you for a type. Do you see the one that looks like a box plot? Go down to type, and then arrow until you get to the box plot. Where we are right now is under the Y equals button, or above the Y equals, under stat plot, and we turn this first plot on, and now we're trying to get to where the different plots are. There we go. That's the one I want, right there. The one that's blinking for me. Okay, so I hit enter on that one. And now notice it says X list. It's going to default to L1 to save you time. If you wanted to actually graph the stuff you had in list 2, that's where you'd change it to L2. All right, and that's right above the 2 button on your calculator. You'd have to the blue second button and then the 2. But anyway, we're on list 1, so that's good. And then I just hit enter, and then I just hit graph. Notice, do you see the box plot that's in with my other graph? You see that little crazy looking thing there? All right, so then how do we make that nicer? Go to the Y equals screen. Clear off your 2 graphs that you had in there. Get those cleared out. And then do you think there's a special kind of zoom that might work really nice for this? Nope, zoom box, you have to pick where to zoom it. Good guess though, because it's a box plot. I get what you're saying. Zoom stat, very good. Zoom stat. You guys have been on fire today. Did you eat your Wheaties or what? Zoom. Where the heck is zoom stat? Oh, there it is. Thank you. Zoom 9. I missed the wrong. Okay. Zoom 9. I'm just going to go right to zoom 9 and enter. There it is. Does that look like a box and whisker to you now? All right. Okay. So you needed to get to stat plot. Turn the plot on, which it looks like you already did. And you never turned it to the... Got to arrow down into here. I got to get that one turned to box plot. And now hit graph. And there it is. Except you got 2 things, so go to your Y equals screen and get rid of the equations. All right. There's a summary of all the stuff you need to know for calculators. It'll help you for future years, hopefully knowing it's there. Do I expect you to remember where absolutely everything is? No. But Do I expect you to know that your calculator is capable of doing all these things? Yes. And then you can always use that catalog if you want to. The catalog button is kind of a cool one to know because you can always find everything the calculator can do in there. You know, isn't it frustrating? You're like, what is this under? I can't remember if it's under math or under stat or under, well, just look it up under the catalog. All right, no homework for today. You guys can chat for the rest of the time.